This is sample 8-5, power in a rowing race from page 344. So in this rowing race, we're given a little bit of information. The distance is 2,000 meters. The time is 6 minutes, which you need to convert to seconds. We're told that the rowers have an average power output of 400 watts and that they use 7.2 times 10 to the 5th joules of chemical energy. So we're asked a couple of questions here. How much internal energy does the rower provide, and how much thermal energy does each rower produce? So the way you should think of this problem is that there's energy that the rower uses, okay? And that's going to decrease their chemical energy, and it's going to increase their thermal energy, okay? So that's what's going on in this problem. Now, when we say how much energy does the rower use, that's part A. How much energy does the rower use? So we're going to use the definition of power, which is work over time, or a change in energy over time. It's not really a change, it's a conversion of energy over time. So we can solve for the change in energy by multiplying the power times the time, 400 watts, and remember a watt is a joule per second, times our 360 seconds. That's why we had to convert the minutes. So that gives us 1.44 times 10 to the 5th joules, that's a 5, that the rower is going to expend during this 6-minute race. So that's the change in internal energy for the rower. So part B then says, how much thermal energy does the rower produce? So the rower is going to use this certain amount of energy that's going to go into rowing the boat and also heating up the rower amongst some other things. So we'll say the change in internal energy is equal to the change in chemical energy plus the change in thermal energy. So everything's in joules. So how does the internal energy change? Well, the rower's internal energy decreases, right? So we have a minus 1.44 times 10 to the 5th joules on this side. We're told that the rower delivers 7.2 times 10 to the 5th joules of chemical energy. So if they're delivering that much energy, then their energy is decreasing by that much. And then plus we have the thermal energy here. So how much is that rower heating up? So solving for the change in thermal energy, we just add, and this number is bigger than this number, so we're going to get a positive over here, 5.76 times 10 to the 5th joules. So that's the amount of energy that goes into warming up the rower. And if it were as simple as a Q equals MC delta T sort of problem, we could figure out the increase in temperature of the rower. But this problem is much more complicated than that. So we're not going to even have that conversation, but that's what we mean when we say that increase in thermal energy. So that's example 8-5, which is the only sample from the power section. And to be honest, the homework section for this is a little thin. You'll get some practice on power on the chapter review, and I believe also on the worksheets. So as always, any questions, let me know.